The consequences of climate change, particularly sea level rise, are requiring us, forcing us to rethink how we live along the edge of the ocean.
We do know that sea level has risen as a consequence of climate change, and that the coastal flooding that was so devastating with Hurricane Sandy was made worse by climate change.
The implications of sea level rise are profound, and we are already seeing that in the 21st century. The smallest amounts of sea level can have devastating effects. They can cause destructive erosion. They can contaminate our agricultural soils and our freshwater aquifers. They can devastate coastal habitats for our breeding, fish, birds, and other wildlife. They can cause problems to do with the magnitude of storm surges, increasing the height and the inland extent of that storm surge. And furthermore, it has profound effects on our infrastructure, our populations, and our economies.
Sea level is rising for a couple of reasons. First of all, when you warm up water, it becomes less dense. So the same amount of water takes up more space, and that causes sea level to rise. But also, sea level is rising because glaciers and ice sheets in the mountains, in the Arctic, in the Antarctic, are melting and adding additional water to the ocean.
People who have houses at the shore know that the flooding is increasing. The flooding is increasing because of sea level rise. And just to give you a sense of that, in the 20th century, sea level rose about 1/2 foot. Today, sea level is rising at about 1 foot a century, but it's accelerating. So you can't just say by 2100 sea level will be 1 foot higher. No, it's accelerating. And it's accelerating because we're seeing faster melting of the large ice sheets in Greenland and West Antarctica.
New Jersey is what some have called a hotspot for sea level rise because sea level is rising more rapidly in New Jersey than it is elsewhere. And that's because at the same time that the water level is going up, the land is sinking or subsiding. That's happening for a couple of reasons. Probably the biggest reason is a vestige of the Ice Age. The weight of the ice sheets to our north pushed the Earth's crust down and caused it to bulge up along the New Jersey coast. Now the ice sheets are gone, and slowly the Earth's crust is going back to where it would have been. So that's causing the land to sink. In addition, taking groundwater out of coastal regions for drinking water is causing the sediments to compact a little bit, and that's contributing to the sinking of the land also.
Sea level rise rates in the 20th century are faster than anything we've seen over the last 2,000 years. And that is a very powerful statement. And if we want to quantify that, the rates that New Jersey experiences in the 20th and the 21st century are 3 times greater than any rate that we've seen over the previous 2,000 years.
You know, if we look at what's already happened since 2000, over the last 15 years or so, sea level has risen by about 2 inches on the global average and about 4 inches here in New Jersey. Over the next 15 years, we would project that it's likely that there will be another 3 to 4 inches globally and 3 to 8 inches here in New Jersey. But there's what we would call a tail risk. You know, we could be wrong. There's about a 1 in 200 chance that sea level could increase by more than 6 inches globally and by more than 1 foot along the Jersey shore over those 15 years. Over the entire course of the 21st century, from 2000 to 2100, if society stays on a sort of fossil fuel intensive growth trajectory, we would project that sea level is likely to rise about 2 to 3 feet globally and about 2.5 feet to 4.5 feet along the Jersey shore. But again, there's a tail risk. There's about a 1 in 200 chance that if we continue on this fossil fuel intensive trajectory, global mean sea level could increase by about 6 feet, and sea level rise along the Jersey Shore could exceed 7 feet. If we cut back on our fossil fuel emissions, we could reduce those numbers by about a foot.
Flooding along the coastline presents one of the most present hazards about trying to live on the edge of the ocean. We all, unfortunately, want to live right up against the edge of the beach, right up against the edge of Barnegat Bay or Raritan Bay. And as climate change affects both the sea level rise, the intensity of storms, and the way the water moves around the coast, it's increased the hazards that are presented by flooding. So when we have big storms like the hurricanes, the Superstorm Sandy, more water comes further inland, comes into contact with more houses and more people. But even on a day-to-day basis, we're seeing changes in the way the flooding patterns happen.
So the largest impact we'll see in New Jersey from sea level rise is its effect on coastal storms. If you think about the amount of flooding caused by a storm, right, it starts at some base level, some average sea level. And if you raise that average sea level, you'll amplify the damage of the storm. During Superstorm Sandy, there were roughly 70 to 100,000 people who were exposed to flooding during the storm, who wouldn't have been exposed had the sea level rise that occurred during the 20th century not happened.
What are people going to do in the future, potentially having to leave those homes and leave places that feel comfortable to them? Those are really big challenges for a community to think about. Where are those residents going to go? How are they going to be displaced? What does that do to the fabric of a community, the tax base?
Sea level rise also contributes to greater erosion on the beaches, greater erosion along our marshes. Our marshes are particularly threatened because they're very, very flat. So a rise of 1 foot of sea level means the marshes want to move back by 1,000 feet. And so particularly along the marshes on the Delaware of New Jersey, the so-called west coast of New Jersey, are very much threatened, and we will see loss of almost 3% of the land area in New Jersey over the next century.
The beaches and the barrier islands in particular of the Jersey Shore are highly dynamic systems. That's their nature. Since the very beginning of time, these beaches have wanted to move around and not stay in one place. And in fact, that movement, the erosion of the sand from the beach off to the offshore is accelerated under sea level rise. In the past, we tried to build walls. What we found very quickly was that the ocean simply moved into the places where the beach used to be, and the ocean would come right up against the wall. The response to that was a very costly process called beach nourishment, where the federal government comes in and pays hundreds of millions of dollars to pump sand back on the beach from the offshore. It's very expensive. It's not a permanent solution because the beaches will continue to do what they want to do naturally, which is to move on and offshore and to migrate. And the rate at which we are being obligated to pay all that money to put the sand back on the beach is increasing because sea level is rising and intensifying all those physical forces that are happening along the beach.
The coastal wetlands of New Jersey are increasingly being thought of as a very, very valuable resource. They are the breeding grounds for our fish, birds, and other wildlife. They protect our shorelines. From storm surges, they stabilize our shorelines. Furthermore, they are a carbon sink, and if these marshes are lost, that carbon will make its way through the carbon cycle into the atmosphere and the ocean.
Really, all the life in the oceans starts along the edge of the shore, in the estuaries where the ocean meets rivers, in salt marshes, in the shallow waters of the bays. You lose the salt marshes, you lose the place where all the fish grow up. You lose the place where the crabs grow up. You lose the place where the blue herons forage, where the hawks look for small rodents. And perhaps as importantly, society, the communities that live along the edge of these salt marshes lose their buffer against the storms.
Many of the residents in New Jersey derive their water from the groundwater mining essentially. Along the coastline, there's a battle between the fresh water that we need to drink and the salt water, which can intrude into these water-bearing beds we call aquifers. Rising sea level means that there's more likely that the salt water will win out in this battle and that we will have our aquifers contaminated by salt water.
In the Delaware Bay shore, you see what are called ghost forests now, where the trees have died along the edge of the bays because of more salt than they can handle now being in the groundwater in which they're drawing on. And then most directly in communities like Cape May, where they've had to invest millions of dollars in water treatment plants to take the salt out of the water, where they're really in a bit of a mad scramble to find new places further inland to put the wells that support all the development and all the people that come to the shore in the summertime. Because as the sea level rises, the salt water creeps further and further inland.
Here in New Jersey, we're in a part of the ocean that's actually warming at about twice the global rate. So in many ways, we're seeing the leading effects of climate change right here off our coast. One of the major impacts we've seen are changes in the fish community. As one example, hake, species that used to be very common off our coast, supported a big fishery, are now primarily found off Massachusetts. On the other hand, black sea bass, another species that's important both to commercial and recreational fisheries, used to be most common off Virginia, is now actually become very common off the New Jersey coast. So we've seen large turnover in the kinds of species that are available to fishers who go off our coast.
Ocean life, and life on land for that matter, has all evolved over the years to live within the context of very specific environmental conditions. They want the acidity of the water to be a certain way. They want the temperature of the water to be a certain way. They want to be a certain mix of fresh water and salt water so that the salinity is at a certain level. And all those factors go into defining the habitat for animals. So as that changes, you're shifting the parameters under which they exist, in which they spawn and reproduce, and it's changing at such a quick pace that the life doesn't have a chance to adapt to it as it has over the millions of years of evolution.
Climate change and sea level rise are a big problem for our coastal ecosystems in the Delaware Bay. We have a lot of shellfish resources that are important to the local communities. There's a lot of shellfish fishing and aquaculture that goes on. And shell fisheries and shellfish themselves are very susceptible to climate change. They're kind of the canary in the coal mine.
As human activity puts more carbon dioxide in the atmosphere, we hear a lot about global warming and increases in temperature as one of the major impacts. But there's this other CO2 problem that we don't talk about as much, and that's ocean acidification, where carbon dioxide actually absorbs into seawater. That creates actually an acid, which lowers the pH of seawater and makes it much harder for many forms of marine life to survive and grow.
Over the past couple hundred years since industrialization, the average pH of the ocean has gone down by about 0.1 pH units. That doesn't sound like much, but if you look at it in terms of hydrogen ions, that's how pH is measured. That's a 25% change, so that's a massive change. And we're looking at probably an even bigger change over the next decade, 50 years.
As seawater becomes more acidic, it's much harder for corals and clams and mussels and oysters as well to create the shells that they use for protection. And so we actually see shells becoming, for many of these animals, becoming much thinner and lighter as the pH goes down.
In general, the scientific projections in terms of climate change and specifically ocean acidification are that the ocean will continue to get less and less alkaline. In terms of shellfish and their need to make shell, that's a big problem because as it gets more and more alkaline, shell dissolves. So they won't be able to make their shell.
This is really fundamental change. We're not talking about one place being polluted or one place being changed. We're talking about the systems on which the planet and the ocean operate. And that's a consequence that we don't really understand, but we're seeing the impacts immediately. So not only is there a consequence to the natural life and the natural ecosystems, but there's a ripple effect onto the communities which depend upon them. And these are effects that in many ways we are not coming to terms with, understanding that they're happening, and really trying to find out answers, one, to stop or mitigate those negative impacts, but in the short term, learning how to adapt and live with them.
It's certainly possible to adapt to sea level rise. There's a range of options we have to look at, though. And some of them may involve moving away from the Jersey Shore, especially as we look forward in time to the second half of the century. In the shorter term, one of the basic things we can do is elevate coastal structures, including our homes. It's likely that there will be, over the next 35 years, up to about 1.5 feet, but there could be as much as 2 feet of additional sea level rise along the Jersey Shore. If you want to add in margins for wave damage, you might even want to raise your home more than the expected sea level rise.
But as we know, living at the shore, we're living in harm's way, and there will be more storms, more flooding, and more of a pain in the neck to keep your shore house.
There are places that are going to become so hazardous that it really is not very wise to try to stay there. And in those places, we should think about relocating. There's often a pejorative characterization of it as retreat. It's really strategic readjustment, because climate change is happening. It is happening now. We are not going to change those stressors in the short term.
Laying the groundwork now to have a strategy to sort of move those people out of harm's way and have a place still in your own community where they can move to is one suggestion that we make to communities. We also suggest reaching out to their community members, not letting people be surprised by what they're going to see into the future, making sure they understand that they're in high hazard areas, that this is a big problem for our community to tackle, and be willing to say, we're taking the front line on this, and we're ready to accept it, and we're ready to start planning for what that's going to mean for our community.
We do need to have stronger regulations in terms of building, both not just for the homeowner, but for large, expensive impact structures. We have to plan better. So, for example, we all know we lost power in many areas during Sandy. Well, those power substations, which were flooded, were placed there at the time of Thomas Edison 100 years ago. And sea level is 1/2 foot higher globally, but it's over 18 inches higher in some parts of New Jersey and 16 inches in Atlantic City. That makes a difference. So we have to plan better going forward.
One of the problems that we have is that we're already locked in. You know, the changes in our temperatures within the 20th century have caused changes in sea level that are irreversible. So we are going to get sea level rise, but if we were able to mitigate against climate change, to start to reduce our temperatures, then we may not face the catastrophic collapse of Greenland and Antarctica. And that is the big worry, because if those ice sheets start to disintegrate, then we cannot adapt. We will be left with a tragic coastal economy, infrastructure and populations. We must remember that 5 of the 10 largest cities in the United States exist along our coastlines. 46% of our GDP is located on our coastline.
There are 2 big things we can do to help fisheries management adapt to changing climates. One is to take care of the basics, to make sure that there are abundant prey, intact habitat, and healthy ecosystems to support the source of food that many of us rely on. The other thing we can do is to actually incorporate changing climates into our rules for how many fish can be caught in a given year. Right now, we don't do that very often.
Unfortunately, over the short term, there's probably very few ways that we can stop global warming, ocean acidification, any of these things. The amount of carbon emissions that we've put into the atmosphere are what's driving all of this cascading effects. Ultimately, if we hope to have any influence on slowing the acceleration of these things. And that's really what we've got to start looking at, is slowing the acceleration. If we can do that, we'll do it through decreased carbon emissions. We need to stop putting carbon into the atmosphere.
In the long term, we're going to have to change the way we live along the coastline. We're going to have to give it a much greater degree of respect to the ocean than we have in the past. Really the arrogance that we can be stronger than the storm or hold back the ocean, I think was one that will ultimately not work for us.
We can solve the problem of climate change. We have the current technologies, we understand the processes. Quite simply, we need to reduce our reliance on fossil fuels. If we do that, we reduce the amount of carbon dioxide in our atmosphere and we start to stabilize our climate.
We are going to need to be much more serious and much more engaged around this issue than we are today. If we're going to solve it, address it, learn to adapt, learn to live with it in a way that minimizes the risks that we put people in, put property in, and in particular the risk that we put wildlife and the environmental quality of the ocean at by our failure to respond.
There's a lot of questions that we just don't know how these things are going to play out. We don't understand how the things that have been set in motion will cause ripple effects and changes and accelerations, etc. And so that uncertainty makes me feel a little uneasy.
I am hopeful about our ability to address climate change going forward. I don't think it's easy, but I think we have a chance if we actually put our minds to it.
I believe we've made great strides in the past 2 years post-Sandy in having communities really begin to own and understand what risks and vulnerabilities are here at the Jersey Shore. So I'm really optimistic that although we may not be in the perfect place yet, that the conversations are starting and the building blocks for adaptation and for increased resilience are being put in place. They are going to have to stay resilient and be ready for what comes in the future.